Hello everyone, my name is Muhammad Zaid bin Zubir and my metric number S50877. Today I would like to present on my final year project research. The topic that I would like to present is study of effects and simulation coaster structure, idealized of Bridge-Pierce score turbulent model using Flow 3D, and my main supervisor is Prof. Madya IR Dr. Muhammad Fadli bin Ahmad. The subtopic that I would like to present is introduction, objective, problem statements, scope of study, significant study, methodology, expected results, and conclusion. For introduction, the risk of local scoring around Bridge-Pierce has been recognized for a long time. According to Richardson et al., claim that the local score around Bridge-Pierce is one of the most common causes of bridge collapses. Downwashing, horses shoe vortex, and vortex shadowing were discovered on a free flow surface around a bridge jet, intensifying turbulence in front, around, and behind the jetty. In addition, the loose bed around a pier creates a unique score hole. Experimental studies have revealed that during the development of the score hole, the flow and sediment transport processes are very complex. For objective, we have three objectives of the research. The first one is to compare results of the laboratory experiment of local score around the bridge with numerical simulation results of CFD code Flow 3D for the verification purpose. And the second one is to test the effectiveness of the numerical model Flow 3D in predicting the score depth around the bridge pier. And the last one is to examine the scale impacts of turbulent flow and sediment score. For problem statements, the characteristics of the pier scoring are often found in three kinds, including local, comprehensive, and contractional scoring. Three-dimensional hydrodynamic models and integrated sediment motion algorithm were established to better anticipate the local score. Many field observation and experimental study incorporate assessment, grading depths, and flow organization. Designers are also aiming to see the bridge for a safe and economic design. Numeric modeling is consequently one of the important components of hydraulic engineering to achieve the flow and sediment field characteristic before the building of a hydraulic structure. Scope of study. The scope of research will compare bridge piers in the coastal structure in laboratory and simulation. Field study by Muller, analysis of the prediction of the crosshair score and measurement in real time in proceeding of the first ICSF International Score of Foundation Conference at Texas A&M, College Station, Texas, USA in 2002. The score equation with field data obtained from major bridge piers. This paper will investigate the transport of sediment using Flow 3D of the turbulent score model. We can observe the difference in wave interaction and sediment movement around the bridge piers from this research. We will use the computer computation to determine the wave pattern to observe the various wave changes if the coastal structure the jetty is applied to the beach. Significant study. Many researchers have proposed a numerical simulation of score by Flow 3D. For instance, using Flow 3D to simulate the flow that occurs in score hole at the base of a circular bridge pier while using a numerical pattern to simulate local scoring in complex tidal flow crossing using Flow 3D to study the effect of piers and their local score depths under different conditions. All this investigation predict that water flowing beneath clear water mostly leads to interaction between the riverbed and flow. For methodology, we start and then we compile validation data with previous experimental data, then we design phase in AutoCAD, then pre-analysis phase in Flow 3D, conduct mesh conversion studies, and if can the mesh be used for the simulation, we go to the first objective is to examine scale impact on turbulent flow and sediment score. First, we set up geometric setup and we run simulation. We examine on turbulent flow and sediment score, and then we compare in experimental laboratory. Then we go to second objective, test the effectiveness the numerical model Flow 3D in predicting the score depths around the bridge pier. First, we geometric setup and model grid setup, and then we run simulation and compare to the experiment laboratory. Then we go to the third objective is to compare result of the laboratory experiment with simulation Flow 3D. We collect all data and then we different solid score, and then we run simulation and compare experiment with laboratory data, and then we go to discussion and conclusion, and then end. For expected result in laboratory studies, two systems, in addition to cinematic amplitude, achieve dynamic similarity when the appreciated forces are in the same ratio. In general, both free node and fraud are extremely difficult to meet in laboratory tests. In scale laboratory experimental modeling, the fraud similarity is frequently used for free surface gravity flow around bridge pair. As a consequence, the term associated with free node in the momentum equation. For conclusion, the numerical simulation utilizing a 3D CFD or flow 3D model consisting of tubular model include numerical effects for fraud and Reynolds. In contrast, either Reynolds or fraud must be disregarded in physical modeling because of problem in respecting both similarity rules. Numerical modeling can therefore better anticipate the flow of turbulences and sit around a bridge pair. On the other hand, it also anticipates that it's difficult to get perfect outcome given the many variables that cannot be accurately represented on numerical simulation. In overall, Fluent show high quality projected flow pattern around the piers despite all the content further thorough and rigorous research is needed to quantitatively verify the finding. Thank you.